All right, so it's Nixie clock show and tell time. What I have prototyped here is the hours portion of the Nixie clock, and I have the two digits for the hours, and I have a counter. This is repurposed from the seconds and the minutes that I had last time, so I tore that apart and I rebuilt it to do the hours. The way it works, so I talked about, before I talked about the designs that had, a base 12 or a base 24 counter, and my last solution was this base 24 version, 58 relays, 51 diodes, too big to fit on the PCB. And so I worked, and I have a little sketch on what I came up with, and it's a hybrid. And so this is actually the first iteration of that hybrid system. When you're in 24-hour mode, there's a tens and a ones counter, so it's a 0 through 10 loop, and then a 0 through 2 loop to take care of 24-hour mode. When you're in 12-hour mode, it's a base 12 counter, and it just loops all the way around, and there's the AM/PM counter. So it's a hybrid of those two. Now this requires 40 relays. I then further optimized it since there's both the tens counter and the AM/PM, and I figured maybe I can combine those, and so I came up with what is now the final design. And I also ran into some issues which I had to correct, which would have been in the other one. So basically, I have a base 12 counter, and so when you're in AM mode or 12-hour mode, you just run through the big loop, and the AM/PM is handled by a 3-stage counter. When it's in 12-hour mode, it turns into a 2-stage counter, and that also selects the meanings of stage 0 and 1. Here means AM and PM. When you're in 24-hour mode, it then turns into a base 10 counter, where this goes 0 through 9, and when it's in 24-hour mode, it's cut short in the loop, and this also drives a 3-stage counter which takes care of the tens position, and in that case, it corresponds to a 0, 1, and a 2 on the tens position instead of just the AM/PM. Additionally, when you're in 24-hour mode, 0 then becomes just a 0. When you're in 12-hour mode, it lights up the 1 and the 2's digits. And the tricky part is handling the rollover at 23, and so there's some logic that this gets cut off between 3 and 4, instead goes from 3 back down to 0 when you're at 2 here. And I ran into a slight logical problem with doing this, because when you're at 23, so the 2 is on, you're about to go to 3, the 2 allows this to switch and shortcut it. The problem is everything changes at once, and so when you transition from 3 to 4 and 2 is on, and 2 is what makes the path short, the 2 goes away, and the bit actually winds up shooting through to 4, and this of course loops around. And so to get around that problem, I made this latching circuit, which basically, when you're at 2, it latches the circuit. It allows, when you're at 23, to go from 3 back down to 0, and this latching circuit stays on until you're at 0, 1. So this is cleared by the 1 counter. So I had to just alter the logic a little bit. It added 2 more relays. But this is a pretty solid design. I'm happy with it, so I can demonstrate it. Here, where to begin? I have a 12-stage counter, so there's 2 stages per row, and there's 4 rows. That's 12-stage counter. Then I have the 0 to 2, or the AM/PM counter here, and like before, have the clock generator, the phase generator, the reset logic, and the preset logic. And then when there's a carry, it comes over here. I have the clock generator again, the reset logic, and the preset. I'm not using the oscillator here. And then these 6 relays here are the things that control the steering of the bits to change the path. So if I power this on, it's going to start up in AM/PM mode, so it's 12. And this is a bunch of relays. This is a bunch of transistors that control the 2 Nixie 2 displays, and I have 2 indicators for AM and PM. So that's AM, that's PM. So you can see right now it's 3 PM, that's PM's on, it's 5, 6, and there's no leading 0. Then it turns to 10, 11, and when it turns to 12, the AM goes on. And so we use the full 12 stages here, and we're only using 2 stages here. So you can see it's 9 AM, 10 AM, 11 AM, 12 PM, just like you would expect. And I can speed it up to show you, sort of see the pattern more. So you see that I go through the full 12 stages of the counter. I flip-flop between AM, PM, changing on the 12, and then I go through 2 stages in the secondary counter. Let me just turn this back to slow again. The AM/PM choice is this switch here, so I can turn that to, the 12-hour, 24-hour mode is here, so I can turn it to 24-hour mode. I'll just reset it. Starts off at 0, and it counts through. And you'll notice as it moves along, it's 0, 8, 9, and it goes back up to 0 in this increments. So now it's 12, 13, and you'll see it go from this, it jumps that, and then it's going to shortcut here. So it shortcuts back to 0. So it goes from 0, 0 to 2, 3 back to 0, 0. And I'll speed that up again so you can see it. So you can see how it goes this truncated path, then it goes on the really short path, then on the truncated path to the really short. And I step through all these sequences, and you can tell, it spends 9 ticks here, 10 ticks here, 10 ticks there, but only 4 ticks on the last stage. Is why it goes really quick. So it's working pretty good. I like the display. They're all synchronized. Everything changes when it's supposed to. I'm glad I have that diagram. And I even now have forgotten what exactly each one of these relays does. But it seems to be working just the way I wanted it to. And so the next stage is to start building the actual counter boards. And I got the chassis in, so I know what the layout is going to be like. Here I have these ribbon cables going to the Nixie tubes with jumpers, and I did a little sample layout where I have a ribbon cable connector, and this one will be able to, if this was like the seconds counter, this would be, the ones, that'd be the tens, and it's just on a ribbon cable. And then I wanted to make sure that I could route the wires to get to the front of the connector, and so that's going to be how you unplug the display from the actual PCB when it's sitting in the chassis. So more progress, onwards and upwards. I still have to work out the spacing of the display, the front panel, where all the switches go, and so forth. That's the next step. But I'm happy with the way the display turned out, and just being able to flip it from one mode to the other. See if it see it went to 12 and went to AM, just like it should. So everything seems to be working, and there's also the software due, which I'll update when I start working on that as well. Once again, thanks for watching. Really happy with the way it turned out. It was, this fist pumping moment when I got it. It turned on. It was just ticking away like it should. All right, talk to you later. Bye.